Okay, guys, today we're going to talk about special systems. And special systems are systems that have either a no solution answer or an infinite solution. Remember that a solution to a system is where two lines intersect. So let's say I had these two lines. Oops, sorry. That's really not straight. Yeah, I got to erase that. I can't go with that. All right. So let's say we had something that looks like this. Not too much better, but we do have an intersection point, and the intersection point is at 3, 3. That would be the solution to our system. So a special system is where they have either no solution or infinite solutions. So a no solution problem would be where two lines do not intersect. So you might have a line that looks like this and a line that looks like this. They're parallel lines. There's no time that parallel lines will ever intersect, so that would be a no solution. Now, if you were writing an equation for a no solution, parallel lines always have the same slope and a different y-intercept. So maybe it looks something like this. Maybe it looks something like this, 2x minus 4, 2x, right? All of these have the same slope. You notice they have the same slope here. The slope is 2 on all of them, and the y-intercept is different. Okay, and this one, the y-intercept, since there's no number there, that's really like saying plus 0. Okay, so if I were to graph these lines, let's start with the top one. The y-intercept is 1, and then it has a slope of 2, so I would go up 2 over 1, up 2 over 1, up 2 over 1, and then I would draw my line, and it looks like this. That's my black line. And then the second one I'll do in red has a slope of -1, and it also has a slope of 2, which means I'm rising 2, and my run is 1, and it looks like this. And you notice rides right alongside, but it will never intersect. And then we'll do it in purple here, a slope of -4, and we go up 2 over 1, up 2 over 1. Again, they have the same slope, which means they're following the same pattern. When they follow the same pattern, sorry, the line's a little bit off, but you can see that it's also a parallel line. And then the last one we'll do here, whoops, I want to do it in green. Okay, we'll do green here. We have a slope of, a y-intercept of 0. And then we up 2 over 1. This one's going to be tight. Up 2 over 1, up 2 over 1, following that pattern. And you can see it'll fall right in the middle. None of these lines will have a solution. So if you look on the graph and they're parallel lines, it is a no solution. If you look at the equations and you can see that they have the same slope, same slope, same slope, all along. The slope is the number that's next to the x. Right? If they have the same slope, that means they're going to have either a no solution or an infinite solution. And if all of the intercepts are different, if the y-intercepts are different, that means they're going to be parallel lines, and that's a no solution. Now, if you were to solve algebraically, and you have something that looks like this, y equals 2x plus 1 and y equals 2x minus 5, and you solve that, I would use substitution here, and I'm substituting 2x minus 5 for that y, so it looks like this. And then I would move the variable to one side, so subtract 2x on both sides. And when you do that, you'll see that the x's cancel on both sides, and all that's left is this. So there's no variable, and it's not equal. So no variable, not equal, that's going to be a no solution. Okay, notice no variable, not equal, no solution. Okay, and the other type is an infinite solution. An infinite solution happens, it doesn't mean that everything works on it. It means that there's an infinite number of solutions. So that would be when it's the same exact line. So they're written in different ways and they fall right on top of each other. And you can see that the number of solutions go on and on forever. So it's infinitely many solutions. That would be infinitely many solutions. So if you looked at the equations, and let's say we have y equals 2x plus 1 and y equals 2x plus 1, you can clearly see that it's the same equation, and that would be an infinite solution. But you may get something that looks like this. Instead of y equals 2x, maybe you'll see y minus 2x equals 1. Okay, and so I would solve this algebraically. So I'm going to substitute this for y. And so instead of writing y, I'm writing 2x plus 1. And then I'm going to continue on with everything the way it was. And now I'm going to solve. So if I look, I'm going to combine like terms. I have a positive 2x and a negative 2x. They cancel out. So I have no x's left, and I'm left with 1 equals 1. So there's no variable, but they are equal. That's going to be an infinite solution. If they're equal, it's an infinite solution. Okay? That would be infinite solution. Or infinitely many solutions. Okay? And that's how we would do. Those are our special systems. Parallel lines with no solution, or a line that falls right on top of another line and it's infinitely many solutions.